The features of Go is name data types. So in addition to our basic data types, int, float, etc., we can actually specify our own named data types. In this program here, I've specified two data types, meters and feet, are both float 64. So again, reading left to right in the Go style, we say that there's a type named meters, which is float 64. And then we can put in constants. So here again is the way we specify our own constants, and I'm using the capitalization to indicate these should be public. So feet to meter conversion and meter to feet conversion. We don't need to specify the names of types for constants. In fact, it's helpful not to. So you'll see there, when I hover over it, it's an untyped float. So we'll be able to use that to do the conversion without specifying a data type. I'm going to create a couple functions here, feet to meters, which will take in a variable in type feet, convert it to meters. And so we multiply feet by feet to meter conversion and then typecast that to meters. So we're allowed to do this multiplication because this is an untyped float. We're multiplying it by something of type feet. Then we have to explicitly say we're going to change it to type meters. Then we have the same thing going on here with meters to feet. We declare a couple variables down here in main. Distance in meters, that's going to be in meters. Distance in feet, that's going to be in feet. Now, it turns out that this kind of thing is really actually important in good software development. If you accidentally confuse your units, bad things can happen. So for example, here we see in 1999, we lost the Mars Climate Orbiter because there were two different software people contributing to that. One of them did their software in standard units, and one of them did it in or metric units, and one of them did it in British units, English units. And so, here's the political cartoon where they've, it crashed because the two different parties were using two different units. And you don't want to accidentally mix things of different units. So by specifying these data types, we can guarantee that we'll get a compile time error if we accidentally try to mix them. So if we try to add a distance in meters to a distance in feet, you'll see that there's going to be a compile time error. There we go. So we have an invalid operation, distance in meters plus distance in feet. We have mismatched types there. We'll comment that out. We can fix this by converting one data type to the other. We're converting feet to meters using the function. We pass in distance in feet. We're going to get back a distance in meters. We can add those together. And similarly, to convert meters to feet, we could pass in a distance in meters, convert it to feet, add them. And now we'll be able to run this out. And you can see that we had 100 meters, 328 feet. When we added those two together, we had 200 meters or 656 feet.